Hello friends. In my videos, I've repeatedly talked about controllers and luminaires based on addressable LED strips running on WLED firmware, which offers extensive functionality and a wide range of effects and color palettes. These devices are easy to assemble yourself. I've shown how to do this, or you can buy ready-to-use ones, particularly from the well-known Chinese brand Gledopto, which produces an entire line of such controllers. One of their products, a ready-made luminaire on WLED, is used in my smart home system. You'll find a review link, along with other previously mentioned ones, in the description under the video. Today, we'll talk about the Gledopto GL-C-009WL controller, running on WLED firmware, designed for controlling addressable LED strips with a power supply voltage of 5 to 24 volts. Device type: controller for controlling addressable LED strips. Model: Gledopto GL-C-009WL. Control module: ESP32. Firmware: WLED. Operating voltage range: 5 to 24 volts. Maximum current: up to 10 amps. Guaranteed diode control: up to 800, but can handle more. Types of diodes: WS2811, WS2812B, SK6812, and others. Operating temperature range: -20 to 45 degrees Celsius. Size: 23.5 by 48 by 89 millimeters. The device comes in a small cardboard box with Gledopto's branded design. Along with the controller, the seller included a standard 3-wire cable with a connector for connecting the strips. The box indicates which model is inside. There are several visually identical options that differ from each other by the control module: ESP8266 or ESP32, the presence or absence of a microphone for using sound to light effects, and models with a port for installing your firmware. In my case, it's the ESP32 version without a microphone. In addition to the controller, the box contained a small manual in English and a piece of double-sided tape. I've already mentioned the cable with the connector. The manual is universal for all models. Here you can see the differences between them. It also indicates that by default the output is active on GPIO 16. The second controller output, on GPIO 2, can be activated if necessary from the interface. I'll show this moment later in the review. Externally, it is a standard controller for LED strips. The front side indicates the model and parameters I've already mentioned. The button on the case has several functions. A short press turns the strip on and off. Holding it for 1 second changes the color, and holding it for more than 10 seconds resets it to factory settings. On one of the sides, there are 6 terminals. To connect the strip, you need 3, plus, minus, and data line. Accordingly, you can connect one strip to the controller, GPIO 16 is active by default, and a second one to GPIO 2, which I'll explain in more detail later. On the other side is the power supply. Depending on the type of power supply you use, it can either be 2 wires to the terminals or a standard round DC connector, 5.5 by 2.5 millimeters. The back cover is held by several latches, making it easy to disassemble the controller. You just need something flat to pry it open. As I mentioned, this model is built on the ESP32 WROM module. In the description under the video, I'll leave several links to tutorials showing how to make such a controller yourself. However, for voltages above 5 volts, you'll need to add a DC converter. Everything is assembled with high quality, and I have no complaints. Considering the low price, this is a good option for those who don't want or can't deal with soldering. Here you have a ready-to-use factory-assembled controller. There is no difference which power connector you use. They are paralleled. You can connect either the wires or the round connector. Let's move on to the connection. 3 wires are used here: red for power, VCC contact, black or white for ground, GND contact, and green for control. Using a flat screwdriver, press through the hole on the front side of the terminal. Insert the corresponding wire and release it. If everything is done correctly, when first turned on, the strip, in my case, a 1-meter piece with 60 LEDs for testing, will light up with a yellow light. The controller will have a green LED lit. The voltage you need to supply to it depends on the working voltage of the strip, which in my case is 5 volts. After this, a new Wi-Fi network named WLED will appear in the list of available networks. To connect to it, use the password LED 1234. Then, Either click on the authorization request or manually enter the address for 3.2.1 in the browser to go to the Wi-Fi settings section. Here, manually enter the name of your home Wi-Fi network. The device supports only the 2.4 GHz band and its password. You can leave the address fields blank, in which case the router will assign it automatically. Click the Save button, and after rebooting, the controller will connect to your home network. In my case, it was assigned the address 192.168.0.207. In the browser, this time using my laptop, I go to this address and reach the WLED control page. For correct display on the computer monitor, PC mode should be enabled. Let's go to the configuration section and make some settings. We'll start with the LED preferences section. The maximum current is set to only 850 mA by default. This is done to prevent accidentally damaging the power supply with powerful strips. I plan to use it with a 5 amp power supply, so I set the corresponding limit. The actual consumption will depend on the selected strip and its length, but will not exceed the value set here. Below, you set the number of LEDs in the strip. In my case, I set it to 300. It's important to specify the exact number as many effects depend on this. There's also a color order setting. This can vary depending on the strip type and needs to be set correctly to ensure colors are not mixed up. To do this, in the strip control interface, turn it on with the power button at the top left, set the solid effect, and select the colors one by one. If the order is correct, the real color of the light will match the selected color. If you see that choosing blue results in red light, you need to select another color order option where, instead of G, there is R in the same position. As I mentioned several times, only GPIO 16 is activated by default. We'll enable and check GPIO 2 a bit later. A bit lower in this section, there are two important options: automatic strip activation in case of power restoration and its default brightness. I usually disable automatic diode activation and leave the brightness at the default setting. After making all the settings, save them. In my previous reviews, I've talked several times about the strip control interface. In short, the left column lists available color schemes, followed by the list of effects. Most effects are sequences of turning diodes on and off, segmentation. The color can be selected from the list, but for some, it cannot be changed. There are also brightness, speed, and intensity settings, and for some effects, additional parameters are available. Ready-made effects can be saved as presets in the right column. Presets, in turn, can be compiled into playlists, specifying their order and duration. Individual, or so-called addressable, control of each diode allows creating effects where, at any given moment, the diodes light up in different colors. Some may be on while others are off. This creates the appearance of running lights, flashes, gradient lighting, and so on. Some time ago, I did a review, the link to which I will also leave in the description, where I showed a similar controller for the Tuya Smart ecosystem, which controlled a strip in the form of a light rope. I connected this very rope to the star of this review, and it works great with it, allowing the use of the vast range of light effects. By the way, you can buy such a strip, a rope, separately without a controller and power supply, and I'll leave a link in the description. As for the power supply, which I already mentioned, it is designed for use in electrical networks with a voltage range of 100 to 240 volts. Its output is 5 volts with a current up to 5 amps, meaning a power output of up to 25 watts. This is sufficient for me. You'll find a link to a trusted store where I get such power supplies, available in different voltages and power ratings, in the description as well. Now, as promised, let's talk about the second output. Why might it be needed? When using long strips, over 5 meters, the supply voltage at the beginning and end can differ, which leads to a drop in brightness. To eliminate this effect, it is recommended to supply power to the strip every 5 meters. Alternatively, you can place the controller in the center and run two 5-meter strips in opposite directions. To do this, we need to activate the second output. In the LED settings section, click the plus sign. A similar strip settings block will appear, but here we specify GPIO2. The length of the strip, in my case, it's a piece with 60 LEDs. But for all effects to work correctly, both strips should have the same number of LEDs. Effects that use the entire strip length will work fine even if two parts with different numbers of LEDs are used. However, effects like running lights, Tetris, and similar ones will only display fully on the longer strip, while on the shorter one, they may display partially or not at all. Therefore, when using two outputs, it's advisable to use strips with the same number of LEDs. Other than the supply voltage, of course, they can differ in type, color order, and can be set individually. Now, about Home Assistant. It natively supports WLED controllers, which will either be automatically detected and appear in the integrations menu, or you can find them manually. If automatically detected, you don't need to enter anything. For manual search, you need the IP address of the WLED controller, the one assigned by the router or set statically. Done. The device is added to the system and ready for use. The main entity is the luminaire, but there are many additional options, including even the firmware, which, by the way, is already newer than the one installed on the controller. Out of the box, version 1.14.1 was installed, and the current version at the time of testing was 1.14.4. The update process takes a few minutes, after which the controller restarts. Done. Now the newest version is installed. In the luminaire, you can control turning it on and off, brightness settings, color temperature, and static color. In addition, the full range of effects is available here, similar to what we saw in the controller interface. For other parameters, such as color palette, speed, and intensity, there are separate entities. You can set the operating mode in two ways, either by running a preset or playlist saved at the firmware level, or by sending all the parameters through automation, which is what I do. This looks like a sequential launch of several services. The first is turning on the luminaire with the brightness value and effect name. Then comes the next service, which selects the desired color palette from the list. Next is the service that sets the desired effect speed. And finally, the same service with the intensity value. In the description under the video, you'll find a link to a tutorial where I show how to organize WLED luminaire control using the menu and a Telegram bot. Gledopto has produced a good and quite budget-friendly product, ready to use right out of the box, which will appeal to those who don't want to bother making such a controller themselves. At least with 5-volt strips, I didn't find any problems during testing. Unfortunately, I didn't have strips with other voltages. In the Gledopto WLED controller lineup, there are options for installation in a wall box, for a DIN rail, and even with a waterproof case. I have written about them several times on my Telegram channel. That's all for now. I hope the video was useful and interesting to you. I'd appreciate your likes, as they help its promotion on YouTube. If you don't want to miss new reviews and tutorials, subscribe to my channel. In the description under the video, you'll find links to this controller, other mentioned reviews, as well as my Telegram channel, Facebook page, and a group for smart home discussions. Join us. It will be interesting. Thank you for your attention. See you soon, and peace to everyone.